Okay, class, in this lesson, I'm going to show you a technique on how to solve an equation. I've noticed that some of you, when you see an equation with a variable, you tend to get lost. You don't know where to start. And hopefully this methodology will help you get some clarity and understand how to start solving an equation. So let me start with something fairly basic, and then we'll add to it and make it a little bit more complicated. So let's suppose we have the following, okay? We have x plus 10 is equal to 5. Okay, so before we get into the mechanics of everything, I want to step back for just a minute and help you to visualize this. This might be helpful for those of you who are visual learners, okay? When you have an equation, you basically have a balance. And what I mean by that is if you think back to your elementary school days, and if you ever had the opportunity to play on a playground and play on a seesaw, what an equation is it's equivalent to a seesaw. So here's what I mean. So you've got a seesaw, okay? And you got this thing that's in the middle, and you've got two people on the seesaw, okay? This is balanced, right? Because both people are sitting on the seesaw and you are perfectly horizontal. The seesaw is perfectly horizontal. Neither one of you is tilted to one side or the other, okay? That's what a balanced equation is. Now, going back to this equation, x plus 10 equals 5, in order to solve for x, we have to go through the mechanics of moving things around. But there are rules to moving things around, because when you move numbers or letters around, you have to maintain this balance, okay? Each person weighs a certain amount, okay? In this case, maybe this person weighs a little bit less than this because of this distance, but don't worry about that. The point is, at the end of the day, the seesaw is balanced, okay? So if we go to this equation and we want to solve for x, we need to isolate x, okay? What I mean by isolate x is we want x on the left side of the equation and everything else on this side. So in order to move this 10 over to this side, we need to do something to the 10, okay? Because this is an x plus 10, we need, in order to move the 10 over to this side, we're basically taking away this 10, okay? So when you take away a 10 on this side, you need to take away 10 on this side. So from a mechanics standpoint, okay, you've probably been taught to do this. You're going to subtract 10 from both sides, and then you're going to solve. Okay, so when you solve, you're going to visually do the subtraction from this level here down to here. Okay, so in other words, you're going to ask yourself, what is x minus nothing? Okay, this blank means it's nothing. Well, x minus nothing means it's still x. So this becomes x. Okay, now you've got 10 minus 10, and when you subtract 10 from 10, it becomes 0. Okay, so this is essentially x plus 0 equals, now we're going to calculate the right side of the equation. Now we got 5 minus 10. Okay, 5 minus 10 gives us negative 5. Okay, why is that? If you think about the number line, and you start at 5, and we go to the left if we go to the left 10 spaces, okay, and the reason we go left 10 spaces is because it's a subtraction. So if we start at 5 and we go 10 spaces to the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We get -5. Okay? So we went from 5 and we jumped 10 spaces to -5. And this is why 5 minus 10 is -5. Okay? So now your answer is x is equal to -5. There's no point in writing out the 0. Okay? Now, I've just shown you how this works mechanically, or what mathematicians will say algebraically. Okay? But if you think about what actually happened, we subtracted 10 from this side of the equation, so therefore we subtracted 10 on this side of the equation. Why do we do that? It's because we need to keep this seesaw balanced. So if you take 10 pounds off of this person, this side's going to get lighter if you do nothing to this side, right? So if you take 10 pounds off of this side, you got to take 10 pounds off of this side. And that way you keep the seesaw balance. In the same way, when you're doing algebra, you're moving 10 over to this side. By subtracting 10, you have to do the same thing on this side. So hopefully that was pretty straightforward, and I believe most of you understand that already. Where it gets more complicated is when there are more steps involved. And here's what I mean. Let's suppose we have this equation, 2x plus 5 is equal to 7. A little bit more difficult, but not much, okay? And here's the reason why this is a little bit more difficult. There are two things involved in solving this equation where you need to isolate x, okay? The first thing you need to ask yourself is, what do I need to do first here? If you step back and look at this equation, you basically have 3 terms, okay? Here's what I mean. You have this term, that's 1. You have this term, that's 2. And you have this term, that's 3. And you have term 1 adding to term 2 equaling term 3. Okay? So when you have this scenario and you have an addition here, this will allow you to move this piece, the number 5, over to the right side. Okay? So this is what it looks like. You're going to subtract 5 from both sides. Okay? Remember that we have to maintain the balance on the seesaw. So you're going to subtract 5 on one side to get rid of it, which means you have to subtract 5 on the other side. And then the result is 2x plus 0 is equal to 7 minus 5, which is 2. So now we're going to rewrite this equation without the 0. So now we get 2x is equal to 2. When you have a coefficient like a 2 next to the x, we have to figure out how to move the 2 over to the other side. So if you think about it, okay, over here to the side, we basically want this to be x equals, and then our answer. Okay, that's basically what we want. That's our goal, that's our objective, that's our finish line. Now, one of the things that we have to remember or recognize is that there is a coefficient in front of this x. It's not written out because it's implied, and it's not necessary to write it out. But the coefficient in front of this x is really the same as 1x equal to the answer. Okay, now I point this out because, like I said, it doesn't need to be written out. It's written like this, but it's implied that there's a 1. The reason I'm pointing this out is because we want to get this coefficient over here to be 1. And the way to make any coefficient 1 is to multiply by its reciprocal. Okay? The reciprocal of 2 is 1/2. So we're going to multiply this entire equation by 1/2. When you multiply this entire equation by 1/2, what happens on the left side of the equation is it becomes 2 over 2x equals, and then on the right side it's going to be 2 over 2. Okay, so let me back up. What we're essentially saying is this becomes 1/2 times 2 over 1 equals 2 times 1/2. And this is 2 over 1. Okay, and I'm going to highlight this a little bit in a different color so you see the difference here. This is 1/2. This is 1/2. And this is 1/2. Okay, so we're multiplying the entire equation by 1/2. When you do that, what results is 2 over 2x is equal to 2 over 2. We know that 2 over 2, or anything over that same anything, is 1. So now we get x is equal to 1. Okay, so hopefully that made sense. Just as a review, the first thing we did was we subtracted 5 from both sides, okay, because we had 3 terms and the first 2 were just being added together. So to move this term over to the right side, we had to subtract. Okay, why subtract? Because this was a positive number. If you have a positive number here and you want to move over to the other side, you have to do the opposite of adding, which is subtracting. If this had been a negative number and you wanted to move a negative number over to the other side, you'd have to add. Okay, here, to move this 2 over to this side, or to get rid of this 2, we had to multiply by the reciprocal. Okay, it's the same thing as saying dividing by the same number. Dividing by 2 is the same thing as multiplying by the reciprocal. So just to make things simpler, we're going to multiply by the reciprocal all the time when there's a multiplication going on here. Okay, so we subtracted here, we multiply by the reciprocal, and that's how we isolate x. So what happens when we add another level of complexity? Okay, here's what I mean. Let's say we have 2 times the quantity x plus 1 plus 4 equals 8. Okay, so this is where it gets to be a little more complicated, because without understanding the first 2 examples that I gave you and jumping right into this, you may be confused as to what to do, how to start this problem. Okay, the way to approach this is to look at this problem in terms of its components. And here's what I mean. Here's a component. Here's a component. And here's a component. Okay. I don't want to say it's a term because the quantity 2 times x plus 1 is not necessarily a term. So I'm going to call it a component. Okay. What you'll see is you've got this component plus this component equals this component. Okay, now you can approach this problem one of two different ways, and either way works. I'm going to show you one way, and that is this. Whenever you have a situation like this where you have a number multiplying by some quantity inside the parentheses, we need to take care of this first. Okay, don't worry about these right now. We have to take care of this first. So to take care of this, we have to use the distributive property. Okay, distributive property means that we're going to distribute the 2 across this term, which is the x, and across this term. So the first thing we're going to do is multiply this. Okay, that's number 1. Then number 2, we're going to do this. We're going to multiply that out. Okay, so when you do number 1, 2 times x becomes 2x. Okay, now the next part is number 2, and we're going to do 2 times positive 1. Why is it positive? Because of this plus sign. So it's going to be 2 times positive 1, and that becomes plus 2. Okay, if this had been minus 1, then it would be 2 times negative 1, and then this would have been negative 1. Okay, so you see how we went from this component here to here? We did that with a 2-step process called the distributive property. Okay, or distributing the 2 times x, that's step number 1, and then step number 2 is 2 times 1. Okay, I'm going to pause this for just a few seconds because it takes a little time to absorb this. Okay, so just to review, to distribute, we said 2 times x, and that's how we got this, 2x, 2 times positive 1, and that's how we get positive 2. Once we have that, then we write out the rest of the equation without doing any other changes. Okay, now let's take a look at the equation. We have this term, we have this term, we have this term, and we have this term. Okay, once you have this scenario where you have multiple terms, before you move anything, you want to ask yourself, is there anything I can combine? I want to simplify it by combining them. Okay, this is a 2x. I don't see any other x's, so I can't really do anything with it. It's like saying 2 apples. Okay, I have a 2 and I have a 4. Can we add these together? The answer is yes. So when we add those together, we get 2x plus 6 is equal to 8. Okay, so now we've got 3 terms left. We've got this term, this term, this term. We have a 2x, which is a term, plus 6, which is another term, equals a third term. Okay, think of the seesaw in the first example. In order to move the 6 over to this side, because this is a positive 6, we need to subtract 6 from both sides. Okay, so if we subtract 6 from here, we have to subtract 6 from here. What we get is 2x plus 0 is equal to 2. Okay, 6 minus 6 is 0. 8 minus 6 is 2. 2x minus nothing is still 2x. Then what we have left is 2x is equal to 2. I'm just rewriting it without the 0, okay? 0 is redundant. And now the next step, if you recall from the previous example, is to multiply the reciprocal. Why? Because we need x to be alone. And in order for x to be alone, the coefficient in front of it has to become a 1. And to make this 2 into a 1, we have to multiply the entire equation by 1/2. Okay, so then what we get is 1/2 times 2 over 1 times x is equal to 2 times 1/2. Okay, this is 2 over 1. So when you multiply this out, let's go up to here. When you multiply it out, this is 1/2 times 2 over 1 gives me 2 over 2. X is equal to 2 over 2. Okay? 2 times 1 is 2. 1 times 2 is also 2. Okay, that's why you get 2 over 2. So now if you look at it over here, 2 over 2 cancels each other out. It becomes 1. And therefore this is x is equal to 1. Okay, so hopefully this made more sense to you, and I'm hoping that these 3 examples will help you to solve equations in the future. If any of this was not clear, please go back to the beginning of the recording and review it again. Thank you.